Hello, welcome to this video. Today I will be talking about basics of quantum mechanics studies and a bit of tunneling effect. So the first animation I'm going to show is what's psi. So we have few equations like the Schrödinger equation, and they give us a function psi, like the Greek letter. So it gives us the form of the wave. Um, so we get a wave, and then we get a probability associated with the wave. So we can know where the particle has a probability to be in. So I know that between 0.16 and 0.57, I have a probability of 40% that the particle will be in there using that function psi. And obviously it varies depending on the integral of the norm of psi squared. So it's kind of complicated, but it will help us to figure out what's tunneling effect. So then I have this thingy here. So it represents a variation of the potential. So imagine you have a particle with energy E. So it's this thingy wingy, okay? And you have a barrier that starts at x equals 0 and at x minus 0 from minus infinity to 0, that is with no potential, and then suddenly reach a barrier. So what if the energy of the particle is greater than the barrier? There is no problem with that, because it's like regular mechanics, because the particle will go right through because it has enough energy to go through, so it's not a problem. However, we will study what we call a barrier, this barrier of potential. We need a quantic approach, because the thing is that the energy of the particle is lower than the energy of the potential of the barrier. So if I increase the barrier and I lower the energy, oops, wait, barrier. Yes, okay. So we reach a case where it's, look, if I lower the barrier settings to be very low, then the thing goes all red, because it's a classical mechanic result. So what we know is we have in green, we have the energy of the barrier, well, the energy of the wave of the particle, and in blue we have the energy of the barrier. So we know that we have a sinus form, and then once it reaches the barrier, it goes into a decreasing exponential. So um, it's called an onde évanescente in French. So it means that the field absorbs the energy of the particle, and obviously we'll get the length of the wave that will influence not very much. No, it doesn't like give anything else. So um, the quantum mechanics states that the wave can't states after being reduced to 0. So there is no way we could have a high probability in x equal 10, since the probability is 0. So when you will integrate psi squared, you will get something very, very close to 0. However, with the tunneling, what happens is you have still a potential V0, that is the potential of the barrier, the energy of the particle. Can I increase that a tiny bit? Okay, and then the amplitude. Well, it doesn't really matter here. So we have this time not an infinite potential, well, an infinite barrier. So it's not from 0 to plus infinity. It's 0 to delta x, which is a very short. It must be short to have tunneling. So you have a small distance, so not infinite. So you have your wave as usual. And then when it reaches this part, the Schrodinger equations gives us that it's decreasing because it's losing, well, not Schrodinger, it loses in energy. However, it doesn't completely goes to zero, and then you reach a part where it's not decreasing, and the Schrodinger equation guarantees that the function will the wave function that describes the probability of the particle to be here will be non-zero, because you see you have a big amplitude, then it decreases, and then the oscillation runs back, but it's very lower. So we have a probability that the particle will go through a barrier, which is not supposed to do it with classical mechanics. So if it was classical mechanics, it will be zero exactly here, well, from 0 to plus infinity. So, however, the quantum mechanics says that there is a probability that the particle will go through that barrier, but obviously the further it needs to go, the lowest the probability is that it will go through. So that's a basic understanding of the tunneling effect. I hope you liked it. If you have any question, feel free to ask them in the comments. Bye!